In the Stone Age, we had bows. In the medieval ages, we had crossbows. And in the modern age, we have all this stuff. Let's get rid of this. Modern militaries around the world spend billions on what? I mean, look, this is just a rocket with knives in it. Instead, I propose we combine the modern age with the medieval age to create a distance detecting head hunting crossbow thing.
Before I can make a head-hunting crossbow, I need a crossbow. And instead of spending $300 on this thing, I'm just gonna make it in computer-aided design software and 3D print it on that thing over there.
I 3D printed this arrow to test the functionality of the base design, and when I pull this back, the elastic cord back, it actually produces a pretty big force output. For example, this is 3 meters, but its consistency left a lot to be desired. Now, some people choose to shoot pigeons, and other people choose to shoot apples. Not me though, I'm choosing to shoot human faces. To do that, I had to write an algorithm that can detect my face. So what it does is it detects my face and it draws a little rectangle around it for you guys to see. The good thing is it's now detecting my face, and that little number that you're seeing up there, that's the distance from my face to the webcam. Now, I'm not going to go into the code and the math because that's really boring and no one wants to hear about that. Let's go. I'm using Open Computer Vision to do the heavy lifting of detecting my face. Basically, it's a model that's trained to recognize this schmuck. The distance to my webcam is calculated using this equation, where symbols have these meanings. The focal length was found through experimentation, and the rest was extracted from the information matrix that's generated when my face is actually picked up. Like any modern weapon, the more automated my crossbow is, the easier it is to use. Pulling the shaft back is okay, but it's for losers. So instead, I'm going to develop a motor and gear system. When a high torque motor spins, it's going to pull back the push shaft and continue doing so for however long it needs to in order to meet the specific force requirement as mapped out from my Facecam script. Wow guys, look at this awesome design I made. And this motor and driver I bought and soldered, and it only took me 3 days. Thank God it worked. So I'm a loser. It didn't work. The main issue I'm having is with the catch and release mechanism. How does the push shaft actually maintain its position when the distance it needs to move back is calculated in real time? Short answer, I have no clue. So I'm going to revert back to a pulling mechanism and utilize these ultrasonic sensors. Wow guys, look, I dropped my ultrasonic sensor into my controller and it assembled itself. I would never lie about that on the internet. Go away. The way these things work is they send a pulse and they receive that pulse. By knowing the amount of time it took to send and receive the pulse, and that the speed of sound and air is this number here, I forgot it off the top of my head, I'm able to calculate the distance that this thing is from another object. So this up here is the output as my controller is seeing it, and as I move my hand, let's say my hand is the object, I move my hand closer and closer to the ultrasonic sensor, the distance it's calculating is decreasing, and I come back out, and it should be increasing. So that's how it works. Right, the program might have crashed, but don't worry, it's not going to be an issue in the long run. It's just because I'm trying to run a heavy program and I'm trying to screen record at the same time, so it'll sort itself out. I made some design changes to incorporate the ultrasonic sensor into the design, and I mean, just listen to this thing. Holy crap. So in front of me over there is my room, and this is the longest bit in the flat that I'm in that I could find to shoot this thing. So in there I've got a camera, and here I'm gonna fire the ammo. Semi-maximum distance test commence. Oh, nice. All that's left to do now is create a system that maps how far I pull the push shaft back in relation to how far a projectile actually travels. Now I could have used some sketchy equations for this, but they all relied on ignoring friction, which just was not realistic for the crossbow. So instead I did some testing and results plotting. I used a cheeky bit of linear regression to map some curves to my data, and I ultimately chose the straight line method because it gave me one value for pulling distance as opposed to 3. So the number in green is how far my face is actually from the webcam, and the number in white is how far I have to push this back, pull this back in order to fire a projectile far enough to hit that face at that distance. Here at Robotcus Industries, we care about you. That is why, over the past month, our expert team of engineers have worked tirelessly to provide you with a new state-of-the-art self-defense system. Recommended by 9 out of 10 military personnel, our state-of-the-art system is great at keeping intruders out and causing harm to your friends and family. With an impressive range of 5 meters, our crossbow system can exert over a minimum of 3 newtons of devastating destruction on the bone structure of the unfortunate recipient of the launched projectile. This artifact can be yours for a mere $10 quadrillion. That's right, for the price of only a small country's GDP, you can be the proud owner of the world's most practical weapon. Now, who do people really not like? Okay, yeah, we're going for him. Allow the shooting of Vlad to commence in 3, 2, 1. Wait, what is this thing here? I built this and I didn't explain it at all, but it is important. Instead of having to carry this big ass monitor around with you, these LEDs tell you all the information you need to know in order to hit your shot. Yellow one lights up when a face is detected. See? Vlad, no Vlad, Vlad, no Vlad. And the green one lights up when the pullback distance to hit the face is satisfied, i.e. if you're good to shoot and hit your target. Apparently I actually need to aim this thing, so alright, pull it back. It's not triggering, it's triggered, okay. And success! Like Vlad here, I'm really surprised I actually got that crossbow done in a month. I'll see you guys next month for whatever I build next. Goodbye.